Welcome back to the deep dive. This one is for you. The operations director, the plant manager, maybe the procurement lead in heavy industry. You're the one who has to sign off on that huge expense when a critical machine just grinds to a halt unexpectedly.
And that is the core economic reality we're absolutely tackling today. Unplanned downtime, even for just an hour, can cost you exponentially more than an entire pallet of the best industrial lubricants.
Absolutely. So we're moving way beyond just buying a commodity. Our mission here is to really shift how you think about lubrication procurement.
Right.
It's not a headache of specs and compliance. It should be a precise, dependable tool for keeping things running and managing your assets. We want to turn that confusion into strategic clarity.
And we've pulled together what is essentially an inside playbook for this. Our whole goal is to cut right through the usual sales pitch. We want to give you practical knowledge that actually gets results. Things that can shave months off maintenance schedules, cut those panicked emergency orders in half, and just make your next audit completely bulletproof.
Okay, let's start with the money. Let's start with the economics, because if you're managing a budget, you have to stop seeing grease as just a consumable.
Not office supplies.
It is not office supplies. It is maybe the lowest cost insurance you can buy for a multi-million-dollar asset.
That is the essential mental shift. Lubricants are an asset protection strategy. We're talking about protecting the really critical components, your seals, your high-load bearings, gear cases.
The whole system.
The entire architecture of those centralized lube systems. If the lubricant gives out, the asset fails. And the real cost, the true cost, is lost production.
And this is where it gets really interesting for me, because the specific the technical chemistry of the lubricant, that's what gives it that protective power. That's what translates to uptime. So when you're looking at a quality lubricant, say like the Lubriplate 630 series our sources mentioned, what are the non-negotiable chemical protectors? What drives performance?
Okay, so there are three main drivers: superior water resistance, robust anti-wear chemistry, and effective oxidation inhibitors.
Let's start with water.
Water resistance is absolutely essential. Think about heavy washdown areas, food processing plants, any place where moisture contamination is just a fact of life.
Right.
If that grease emulsifies or washes out, you get immediate metal-on-metal contact, and that leads to a very, very fast component death.
Okay, and the second point, the anti-wear chemistry. I think everyone listening understands friction, but let's go a little deeper. What is the actual mechanism at play there, especially under a really high load?
That's where we move past just basic lubrication and into really true asset defense. We're talking about what are called extreme pressure, or EP additives. Right. Often things like sulfur phosphorus compounds. When a bearing is under intense pressure or shock loads, these additives do more than just reduce friction. They actually have a chemical reaction with the metal surface.
A chemical reaction?
Yes, to form a sacrificial protective film.
A sacrificial film.
Exactly. So when the load gets so high that it breaks through the normal lubricant film, the sacrificial layer takes the damage. It prevents the pitting and scoring on the expensive bearing itself.
Wow.
If that EP theme is weak, or it's the wrong kind, you lose what's called shear stability almost immediately. And then you're looking at a catastrophic failure in hours, not months.
That's a huge quantifiable risk. Okay, so the final piece of the puzzle, oxidation inhibitors. This sounds more like a maintenance schedule thing than a performance issue.
Well, it's actually both. Oxidation is what happens when the base oil reacts with oxygen. It's sped up by heat, by metal contamination, things like that.
Yep.
And that process fundamentally breaks down the grease. It shortens its life. So by adding inhibitors, you significantly widen your safe service window. You can stretch out those relube intervals without risking damage.
So if we tie all three of those specs, water resistance, EP protection, oxidation control, it all comes back to the total cost of ownership, or TCO.
It does.
You're preventing failures, obviously. But how does stretching out those relube intervals really drive financial savings beyond just the cost of the grease?
The TCO reduction is layered. First, you're using fewer man-hours on routine relubes. Second, you're reducing the volume of used lubricant that you have to pay to dispose of as hazardous waste.
Which is a huge and growing cost.
A huge cost. And third, better longevity means less inventory risk. You don't have to store massive volumes of product for frequent changeouts. It turns maintenance from reactive work into planned, optimized work.
That shift, that efficiency, brings us perfectly to the next point. The need for a shared technical language, maintenance, operations, purchasing. Everyone needs to be on the same page. We need standardization.
You can't manage what you don't measure. And standardization, it really starts with the NLGI, that's the National Lubricating Grease Institute.
The grading system.
It's a grading system. Matching the correct NLGI number to your equipment is the foundation. It gets rid of all the guesswork around viscosity and thickness.
Okay, for everyone listening, let's get specific. What do those numbers actually mean on the plant floor?
So a higher number means a thicker, stiffer grease. NLGI2 is kind of the industry standard. It's great for manual greasing for bearings that need the grease to stay put.
Okay.
But if you're running a high-speed system or a centralized lube system that has to pump grease through long, skinny pipes, you have to use a softer grade, an NLGI 0 or even a 00.
And what happens if you don't?
If you try to force an NLGI 2 through a system designed for 0, well, that's a classic mistake that guarantees starved bearings and pump failure. Understanding that difference is the first step to consolidating your inventory.
And standardization is also about avoiding those really expensive traps. I mean, our sources highlight the Lubriplate 630 series and the 930 series. Let's decode that comparison because it seems strategic.
It is. The 630 series is really defined by its great mobility and its water resistance. So think of products like the 630 AAA or the 630 AAA. They are your versatile general-purpose greases, good for motors, chassis, medium load situations where moisture is the main enemy.
And the packaging seems to reflect that. It goes from tiny 1.75-ounce tubes up to 6-pound tubs. It's designed for convenience, right?
Exactly, for servicing individual assets quickly. The 930 series, though, that's a different beast. The source material calls it a rugged lubricant engineered to stop failures.
So this is your heavy hitter.
This is your high-load insurance. This series, you'll find it in bigger formats like 35-pound pails or 440-pound drums. It's for your most demanding, high-shock, failure-prone machinery.
Okay, so if I'm managing a plant, I might use the 630 series on my utility motors and conveyors, but I need to standardize on the 930 for my primary crushers or my big gearboxes where shock loading is just immense.
And that kind of scenario planning is the key. By using these specific product families, the versatile 630 versus the rugged 930, you get maintenance and purchasing on the exact same page. Using product codes, not just vague descriptions, it eliminates dangerous substitutions.
And that brings us to the mistakes to avoid. The lowest price trap is obvious, but let's talk about the silent killer. Incompatible base oils. Why is mixing them so dangerous?
Mixing incompatible base oils, it's a recipe for immediate mechanical failure. When you combine different thickener systems or base oil types, say a mineral oil with a certain synthetic, you can trigger a really severe chemical reaction.
What happens?
The thickener can separate completely from the oil. You lose all your shear stability. The grease structure just collapses. I mean, one contaminated grease gun can destroy a bearing in a matter of days.
That is a scary thought. And that lack of foresight often leads to the last trap, buying the wrong package size. I've heard stories of maintenance techs wasting hours just scooping grease out of huge drums.
Because procurement optimized for price per pound, not usability.
Exactly. Which brings us to our third section, the procurement and logistics playbook. How do we reduce that inventory bloat by matching packaging to the actual consumption rate?
You have to map the format to the delivery method. It's that simple. If you're out in the field with a grease gun, you need that portable 1.75-ounce tube for control and to avoid contamination.
Makes sense.
But if you're refilling a large centralized system, you need the 35-pound pail or the 440-pound drum. Buying the wrong format just creates this wasteful mess in your supply chain. You get spillage, contamination, and a ton of internal friction.
And it's not just the product, it's the supplier relationship. For this audience, you're not looking for just a vendor. You need a partner who provides operational certainty. What should they be demanding?
Technical consultation is completely non-negotiable. You need guaranteed access to support for your MSDS documents, for compliance verification, and for shelf life strategies. And maybe most importantly, you need predictable, transparent lead times.
Right.
If your process always ends with you paying for emergency air freight shipments, you're paying a huge premium for a failure in your planning, and your supplier is letting it happen.
Okay, let's wrap this up with some tactical, concrete moves. What can our listener do literally next week to put these insights into action?
First, refine your requests for, quote, your RFQs. Don't just ask for NLGI2 grease. Use specific spec checks. Ask for the NLGI grade. Confirm the base oil type mineral or synthetic and demand performance data like 4-ball weld load results. Make them prove it.
Good one. Okay, second.
Put a checklist in place today for evaluating new grease compatibility and storage. That's the only way to kill that risk of mixing incompatible products that we just talked about. And this one is huge. It eliminates the whole panic cycle. Learn how to calculate your reorder points precisely. Get your safety stock model right. The formula is simple. Reorder point is your demand during lead time plus your safety stock. Getting that right ends emergency air freight overnight.
And finally,
arm yourself with a few key questions for every supplier. Ask them about their inventory programs that fit your actual cycle counts. Ask them about their technical support availability when you have a problem. Distinguish real service from just a sales pitch.
Okay, so to summarize our deep dive today, smarter purchasing, standardized specs like NLGI grades, or key chemistry like EP, anti-wear, and optimized packaging logistics.
Those are the levers. That's what keeps production humming and your compliance solid. It's about eliminating waste and friction all the way through the supply chain.
We've seen how choosing the right format and the right spec protects your most valuable assets. But the real power, the fundamental gain here, isn't just in the protection. It's in the predictability.
It all comes back to that.
It does. When your technical specs and your procurement logistics are perfectly in sync, it transforms lubrication from this, fluctuating necessary expense into a measurable, predictable tool for increasing uptime across the entire organization. So we'll leave you with this final thought. What other seemingly simple, low-cost component in your operation, maybe a filter, a gasket, a sensor, is hiding a similar strategic opportunity? An opportunity for predictability and massive cost avoidance if you just apply the same deep dive level of analysis. Think beyond the grease gun.